Lesson 8.4, Polygons and Angles. A polygon is a closed figure whose sides are line segments that intersect only at their endpoints. For example, this would not be considered a polygon because that is not connecting at the endpoints, where this would be a polygon. Also, it needs to connect. Because this is not connecting, that's not a polygon. A regular polygon has all sides of equal length and all angles of equal in measure. A pentagon has 5 sides. It is a polygon with 5 sides. A hexagon is a polygon with 6 sides. A heptagon is a polygon with 7 sides. Octagon is a polygon with 8 sides. Those are the ones that you're going to need to remember. Example 1. Is the figure a polygon, a regular polygon, or not a polygon at all? For A, because they're intersecting at other places besides the endpoints, like that's an endpoint right there. Because they're intersecting at other places, this is not a polygon. Part B, you can see that they intersect at only the endpoints and it's closed, but is it regular? So it's definitely a polygon, but is it regular? Well, it doesn't look like all the sides are the same measurement. So it is a polygon, but not regular. And it has different angle measurements. To find angle measures in a polygon, we use the following formulas. Now, let me remind you, this is like when we had a triangle and we add up all of the angles, it equals 180 degrees. When we had a quadrilateral and we add up all the angles, it equaled 360 degrees. So if I have a 5-sided shape, how can I tell what the angle measures will equal? You take the number of sides, that's what n is. Okay, again, n is the number of sides, and it says that in that little bubble. And if you need to identify a polygon, if you haven't learned its name, you can say a 13gon is a 13-sided polygon. So you just say n-gon. So if it's a 12-sided, you can say 12gon. So take n minus 2 and multiply by 180. You can see that works for a quadrilateral. If I do 4 sides, minus 2 times 180 is 2 times 180, which equals 360. And that's what we knew about a quadrilateral with 4 sides. Now sometimes if it's a regular polygon, a regular n-gon, you can find one angle measurement by taking that same formula, n minus 2 times 180, and dividing by how many sides there are. So for example, with the quadrilateral, 4 sides minus 2 times 180, and again, we knew it was 360. Take 360 then, divide by the number of sides, which was 4. And you can tell that that's 90 degrees. And that makes sense because a regular quadrilateral, regular polygon with 4 sides, is a rectangle or a square. Actually, I guess it would be a square because it has to have the same equal length. And squares have 90-degree angles. So let's find an angle measure of this shape, which is a hexagon. How many sides does a hexagon have? Well, you can count them, or you should know that a hexagon has 6 sides. So n equals 6. Here's that formula again, okay, that you need to know. And I believe they put this on the PSSA formula sheet. This is one of the ones they put on there. So take 6 minus 2 times 180 and divide by 6. So 6 minus 2 is 4. 4 times 180 is 720. Divide by 6 sides, 120. That means every angle measure, because this is a regular hexagon, is 120 degrees. Every angle measure is 120, excuse me, 120 degrees. Again, I could do that for each of them. And that should add up to 720. For number 1 and number 2, let me write down the formulas for you. We're just finding the sum. Now, you have to remember which formula is which. The sum is just n minus 2 times 180, where the measure of one angle is n minus 2 times 180 divided by how many sides there are. Pause the video and complete 1 and 2. In number 1, we have a heptagon. A heptagon is 7 sides, so I'm going to put 7 in for the n. 7 minus 2 is 5 times 180 equals 900 degrees. For number 2, it's a 12-gon, so we put 12 minus 2 times 180 over 12. This is 10 times 180 divided by 12. 150 degrees is each angle measurement.